Welcome to Amplified Education, your exam prep friend. Today I'm going to be looking at Newton exam questions. Please pause the video and try these questions on your own. The question reads two boxes A and B with masses 5 kg and 10 kg respectively are connected to by a light inextensible string as shown in the diagram. A force F is applied to the 10 kg box which is box B at an angle of 30 degrees to the horizontal, as shown. The system moves along a horizontal surface at constant velocity. The coefficient of kinetic friction between both boxes and the surface is 0,025. The first question says we must state Newton's first law of motion, and the law states that an object will remain in a state of rest or uniform velocity unless it is acted upon by a net force. The second question says, explain what would happen to the system if the 10 kg box were to come to an abrupt stop in terms of Newton's first law. So in terms of Newton's first law, if the 10 kg box comes to a stop, then the 5 kg will continue moving because of its inertia. And then it would obviously collide with the 10 kg block, and then there would be a change in momentum in both boxes, which might cause the 5 kg to come to a stop and the 10 kg to move forward, or might cause the two boxes to attach to each other as a unit and continue moving together. But according to Newton's first law, the inertia of the 5 kg box continues to cause the box to move in a straight line with its original velocity when it was traveling, that it was traveling with just before the 10 kg box comes to an abrupt stop. Then 1.3 says we must draw a fully labeled free body of all the forces acting on the 10 kg. So that is 1.3. On the 10 kg, we have an applied force, Fa. Then there's also a normal force, Fn. And then we have friction, which is Fk. We also have tension, Ft. Then we have Fg. So those are the forces that are acting on the 10 kg box. And I prefer drawing the components of the applied force for easier calculation. And so we have the normal force Fn, then we have Fy, the vertical component of the applied force. We then have Fx, we then have Fg, and we have Ffk, and we also have Ft. And then 1.3, and remember, you must always draw a key, like you write a key for the forces that are represented in the free body, clearly explaining what those symbols represent. So Fa represents the applied force, Fn, the normal force, Ft, tension, Ffk, kinetic friction. Then 1.4 says we must define the term velocity. I'm not going to write the definition down, but velocity is the rate of change of position or the rate of displacement. Then 1.5, let's go to 1.5. 1.5 says we must write an expression for the normal force of the 10 kg box in terms of F. So obviously, if we look at our free body diagram, there are three vertical forces, and two of those forces are pointing up in the same direction. So those two forces must be equated to the gravitational force in order for us to determine the normal force. And remember what I always say, that because the force F is acting at an angle, there's a lifting force Fy that causes the 10 kg box to be in less contact with the ground, thus reducing the friction that the 10 kg box is experiencing. So we could say here that Fn plus Fy gives us Fg. And then we could say Fn, maybe just write that next to there. Fn is therefore then equal to Fg minus Fy, which is equal to, now remember, Fg is equal to mg, which is 10 times 9.8. That gives us 98. And then minus F sine 30 degrees. And that would be our expression, all right, for 2 marks. Then it says in 1.6, we must calculate the value of F for about 7 marks. That's 1.6. So what we're going to do, we're obviously going to set up, let's set up 2 equations, all right? But maybe before we set up 2 equations, let's find the tension between the 2 boxes by particularly focusing on the 5 kg box. Now we know that there are 2 horizontal forces that are acting on the 5 kg box, and that is Ft and FFK, all right? And obviously we also have the vertical forces Fg and Fn. This is particularly for the 5 kg box. So for us to determine, first and foremost, the normal force that is acting on the 5 kg, that would be equal to Fg, which would then be equal to mg, and that would be equal to 5 times 9.8, which is then equal to 49 newtons. Then from there, we could find the frictional force that that particular box is experiencing. We already have UK, and then we can just multiply that by Fn. So that is going to be 0.025, multiply that by 49. 0.025 multiplied by 49, you get 1.225. So that's 1.225 newtons. That is the frictional force that is experienced by the 5 kg box. But we know that if the system is moving at a constant velocity, then the tension that the 5 kg box is experiencing should be equal to the kinetic friction, all right, on that particular box. So Ft is equal to FFK, which is equal to 1.225 newtons. Now, that very tension that the 5 kg, that is exerted on the 5 kg by the 10 kg, would be equal to the tension that the 5 kg is exerting on the 10 kg according to Newton's third law. So we can set up an equation again by looking at all the horizontal forces that are acting on the 10 kg block. So if we just focus our attention now to the 10 kg box, I keep on saying block, it's a box as per the question. So the Fx that is exerted on the 10 kg should be equal to the FFK, right? The FFK plus the Ft. That would be the expression, right? That those forces are equal to each other but opposite because of Newton's third law, but again, Fx is equal to ffk plus ft because the system is moving at a constant velocity. Now, if that's the case, we can find an expression for f of x in terms of f, which would be f cosine 30 degrees. Then we can find an expression for ffk, which would be for particularly the 10 kg block would be ffk equals uk Fn, and that would be equal to 0,025 into this expression of Fn that we calculated earlier on. So that would be 98 minus F sine 30 degrees. Then we could distribute that, and then say 0,025 multiplied by 98. Then we get 2,45 there minus 0,025 sine 30 degrees. And we get minus 0,0125 F. Okay. So that would be the expression 2,45 minus 0,0125 F plus Ft, which we already have as 1,225. Right. And then we can just simply isolate the F now. If we isolate the F, make F the subject of the formula on the left-hand side, we would have the cosine 30 plus 0,0125. That gives us 0,879 F. And that is equal to 2,45 plus 1,225. That gives us 3,675. And then if we make F the subject of the formula, we divide that number by 0.879 and we get 4,18. 4,18 newtons. So that is the force that is applied. And then the next question says calculate the tension in the rope. Remember that tension was already calculated in the previous question. So that question is not necessary. And then 1.7, or rather 1.8, let's jump on to 1.8. 1.8 says the angle at which the force applied, the angle at which the force is applied decreases. How will this affect the friction acting on the 10 kg box? And so obviously the friction should now increase, right? The friction should now increase. The reason why the frictional force is increasing is requested on question number 1.9. So now remember, if the angle theta decreases, right? Then what actually happens is that the 10 kg box increases in its contact with the ground. Basically, the contact between the ground and the 10 kg box increases, which causes the frictional force to increase. So when theta decreases, then we know that F of x should increase, but F of y should decrease. Now, remember that the normal force is equal to Fg minus Fy. So if the value of Fy decreases, then the normal force should increase. All right, and if the normal force increases, do not forget that FFK is directly proportional to the normal force as given by the equation FFK equals UK multiplied by Fn. So if the normal force ultimately increases because the value of Fy has decreased, then the kinetic friction should also increase. And that's pretty much how you would answer that. I hope that helps. Thank you.